I am so confident in my inability to do well that I would bet on
Wait, what? Let's say that this is now 3. Whoa!
That means it needs 12 of them, which means you give them 12.
9?
No, what?
What?
Only
Why
Why are you saying no to me?
No, there's 3 of them.
9.
9!
Oh, it's not. Good job.
9! Oh, the number 9, not 9! Okay.
It's not.
Alright.
You high five.
Yeah, that's it. So the total here, it needs
Okay.
it needs 9, right?
So you just multiply by the charge and multiply by the actual number.
Yes. So this is it's the charge. It says in the little sheet right there. It says -3. So now this needs a total of 9 because of this. That says that there's 3 of those. Okay.
Wait, this is what I was confused about now.
I know.
Why did you write 9?
Wait, okay, so this.
It's 1, no. It's
It's
guys.
X. What X? What X?
Stop.
No, it's not X.
Stop.
You just
It's
put
a
9
1.
dashes.
It's a
Time out.
V.
Time out here.
V with 4 1.
Okay, time out. So there's 3 PO4s. There's 3 phosphates.
That's right.
Okay. And phosphate has 3 charges.
Yeah. -3 charges.
So
Yeah.
so 3 of them, so it's 9.
Yes.
That's right. You
Okay.
just said exactly the same thing you
I'm
said.
literally just saying it again.
You
So,
repeat
Okay.
yourself.
so I did.
All right.
Continue the lesson, please.
All
Are
right.
you gonna make it even harder or are you gonna spare us?
I
I think we got it.
I
You
got
got
I think we got it. Okay.
Then we got
We can go the opposite way too, just like we did with the other kinds of bonds, but I won't bore you with that. Treat this as if it's just a regular non-metal. Okay. That's it. And it tells you how many it needs. So you're good. All right.
Didn't even stop.
Vesper or Vesper.
The separate.
The Zephyr.
Okay. These kinds of questions I always ask you in the context of like Lewis dots and so forth. So the question will be something like, first, I'll give you a chart. I'll just tell you this. I'll give you a chart where you're going to need to know, I'll say first the formula,
And then you need the structure.
and then you're going to get the Lewis dot structure,
And then it's the molecular shape.
and then I'll say, yes, it'll be the shape, it'll be the Vesper shape. Wait, I spelled that wrong. Vesper. And it'll be is it polar?
Nah.
Wait, which one?
And then it'll be finally, I love these questions because there's so many things in there.
Wait, which one are we doing?
IMF at the end.
Which one? Oh, we're doing including all of these.
Yeah, let's do a couple practice. You two are way too good of friends right now. Now, these formulas, there'll be some that are easy and then some that are challenging. I'm not going to give you a whole catalog of these because I find it just wastes people's time, and it doesn't really get to any more understanding. So you'll have an easy one, a medium one, and you'll have a hard one. Okay?
We have to know which, for the vessel, which one we have to know the molecular structure of the left.
So it'll be the molecular shape. Good question.
Yeah, that's what I meant.
Yes. That's what I mean. Good. Molecular shape. And you'll need to know the bond angle for that too.
What?
Bond angle.
Are we combining the vessel with the polarity?
Well, they all kind of go together.
So we're just doing those 3 together like right now.
Yeah.
Pretty
All right.
intense.
Let's use let's say this is an easy one. I'll do this CH3 and then NH2. Yes, that'll work. All right, CH3 NH2. So for the Lewis dot, I'll give you some space for this. You'll have C and then you'll have the 3 H's. Notice how I'm doing this. I'm writing it out like this. Every time there's like a new set of H's, I write a new line.
I like.
Okay, dude.
No, I put my structure that
It's okay.
I can't. It is.
Right here, I'm going to connect all the single dots, right here.
I want the single dots.
Those are all, that's kind of a bad connection. You can see that they're all connected right there.
No, I understand.
Good, it's all clear to you now.
But for what?
No, God, I don't get it.
Oh
Oh, no,
no.
I get it.
Oh, no.
Okay. I got it. I got
What?
it. I'm making the diagram.
Uh-huh.
Wait,
I
with
mean,
that?
So the final diagram is going to look like this. I'll show you. See? Oh, whoa. What am I
It's not that easy.
I'm so confused. Why are you guys laughing?
doing? You're a little bit goofy.
Why aren't you laughing?
I'm trying to be serious and like actually learn chemistry.
Oh.
Ooh.
All right.
Someone came with a sassy pants on.
Excuse me.
It's the truth.
Oh.
Oh my god.
That's actually just how I do it.
Wait,
Okay.
why would you that?
Mine's to the side.
I drew it like this. Okay, so now we need to refocus, guys. You got it a little bit too goofy. So right there, let me see. You've got. That's the same.
Okay.
It's the same thing.
Yeah,
Yeah.
mine's.
This is my version of it. You can have these H's on different sides if you want. Just make sure that there's 2 electrons on one side of the end. All right? And that's it, right there. So now what I'll do also, I'll say with. Oh, what have I been doing? Putting things all over the place. Here, I'd say this is bold. I'd say this N right here is bold. Ignore that guy.
Why?
And I'll say, figure out what the molecular shape is around the bold atom. That way you'll know which central atom I'm talking about.
Wait.
Okay?
Oh, you're gonna bold it.
I'll bold one of them, and this one I bolded. So that means I want to know what the shape is around that N.
So it's a trigonal pyramid.
Yes.
Trigonal.
Trigonal.
It's the same thing.
But she said it better.
I had
So it's
Ooh.
trigonal, pyramidal. And we know this because there's a lone pair on
No,
it,
but
and there's 3 atoms bonded to that
Okay,
N.
so
Question from Nino and question from Gabe.
there's like, there was, you can get back to me.
Okay.
Okay.
So it's, let's say you ask for the molecular shape of carbon.
Yeah.
What would it be? Because there's 4 and then there's 1 lone pair, right?
Right, but the lone pair isn't on carbon, is it?
So it wouldn't matter.
It wouldn't matter.
So it's just potential.
Yes.
Oh, okay.
Yeah.
So, for one of the practice problems, it was SO2, and it was bent,
Mm-hmm.
but I didn't understand why, because bent has 1 lone pair, but there's
It's the
2 lone pairs.
no, because
There's 2 versions of bent. There's one of them
No,
that has lone pair, and the another one has 2 lone pairs.
so
like
yeah, it
water's
has
bent.
2. It has 2. Look, how did you draw it? Wow. Well, I drew it like.
There's 2 versions of bent, Neo. One of them has a bent at 120 degrees, the other one's bent at 109.5. So the one that is in the SO2 example, that's 109.5 degrees, it's bent.
Oh.
You just have to convince yourself of it. The chart shows you that there's one of them that has a lone pair, 1 lone pair, and has 2 atoms bonded to it. That's still bent, but it's at a lesser angle.
I think this is yours.
Okay.
Yeah, you're right.
I don't understand like that kind of part. I understand like that has like 1 lone pair. And
Right.
there are 3 members of the
I have
atom.
to.
Wait,
Okay.
one of these trigger. How would you know the degrees between
There's 3 degrees that you need to know. One of them is 180, the other one's at 109.5, and the other one's 120. The only time it's 120 is if it's, let's say,
1 lone pair, 2 atoms, 0 lone pairs, and 3 atoms?
that's right, when there's 3 things sticking out of the atom.
Oh, so when it's like the 3 bridge down, that's when it's 120.
Yeah.
Okay, and the rest are 105 when there are 3 atoms in the lone
Yep.
pair.
Good. Okay, and is it polar?
Yes.
No.
No.
Wait,
Is this,
wait,
when I
wait,
say
wait,
polar,
wait,
do I
time
mean
out.
the entire thing, or what do I mean?
We're talking
No,
about
just
because
the nitrogen.
The hydrogens, the arrows on the hydrogen that we up and put emphasis on
Yes.
the lone pair.
This is definitely polar.
So it's-
Now, this might get difficult when you have larger atoms, but for this one especially, the whole thing, or I'm sorry, larger molecules, the whole thing, I just drew a whole bunch of dipoles in there just for fun. In here, you can see that it's definitely off balance. The whole molecule is off balance, so this thing is polar. Yes.
It's like
Polar.
further away.
And the IMF here, what's the IMF going to be?
What's the IMF?
Is
no,
let's imagine.
Wait,
H
Van.
and N, it's gonna be H bond.
Yes! It's going to have nitrogen and oxygen. They're connected, so oh man, that's a special case. where we have N and H together. That's going to be a hydrogen bond. H bond up in here.
Mine is the only one that got all that, and I literally understand.
Oh, I got it. It's like NHHOAF. Nothing's H.
Well, we're focusing on
Yeah.
the N and H is one of the HO, HF, and
Do that
HF
again.
big sections.
That's correct.
Oh.
You know what Cheers was here today?
Was he?
Like, you didn't see him? He was here, he was like, I was walking and like, and then he just came like,
Okay.
See you later. Okay, that's it. Alright. So,
Okay. Polar because nitrogen's taking the like the going towards
When it's non-polar, it's one where it's like HCl, right? And it's like going in one direction.
that is polar.
What direction? When it's
non-polar.
Hey.
Non-polar is when it's like all of them are like they cancel each other out.
Oh, right.
Yeah. That's when they cancel all each other out.
Which
example
it's
of
like-
that
it's like-
for the next.
It's
Sure.
like the 4 H's in the C.
4 H's and a C.
Oh,
Yes.
right, okay.
CH4.
So when it's usually 4 atoms, it's always going to be non-polar. Oh, or when they're 2 atoms with a triple or double bond.
So you know we can just write like H bonds. That's
Yeah, that's fine. For the IMF, just write H bond. That's fine. Now, let's say that this N right here wasn't an N, but in fact was, let's say, I don't know, let's say there was another C and there's another H involved here. Oh my God. Let's say that this is right. Let's just say that this formula over here was not NH2, but it was CH3 again. Oh my God. What will be now the new, this would be all different. But the Lewis dot would be this. And-
CH3, CH3.
This would be like that.
does it what? Can it just be 2H6?
Oh, did I not? It could be just C2H6. It could be. I could say that if I wanted to, but I just drew it out like that. And what would now be the new molecular shape and the new bond angle for, let's say, this C?
Tetrahedral.
Yeah.
And it'd be one
Give us
1.5.
something to answer,
And then it
please.
would be non-polar.
Thank you, Molly.
It is
Yeah,
not
keep
an H
going.
bond.
There you go. Thanks, Molly.
No. And it would be, what would it be?
Wonderwall.
Van der Waals. Yeah.
Van der Waals.
Van der Waals.
I'm not gonna do it.
There it is.
Oasis.
So you should say.
That's right. Good. Okay. And the only other version of this would be